All right, part 3, last part of our section on 8.3 parabolas. So 2 more examples. These 2 last examples have different characteristics than the others had. So let's see how these guys behave. F of x equals x squared plus x plus 6. So opens up or down. Leading coefficient is 1, so it opens up because a is positive. Let's find the vertex. The x-coordinate vertex is the opposite of the coordinate in front of x, all over twice the leading coefficient. So b is 1, so it's going to be -1 all over 2 times 1. Yep, working with a fraction again. -1/2, you can handle it. The y-coordinate of the vertex, we stick -1/2 into this function. Great time to practice. -1/2 squared plus -1/2 plus 6, 1/4, -1/2 plus 6. Let's see, I got 23/4, so hopefully that's correct because that's what I'm going with. So therefore the vertex, remember, is an ordered pair, and it's -1/2, 23/4 for this example. All right, once we know the vertex, we know the equation of the axis of symmetry. So remember, the equation of the axis of symmetry is always x equals, and then the x-coordinate of the vertex. The y-intercept, we let x equal 0, and if x equals 0, the function evaluated at 0 is 0 squared plus 0 plus 6. So notice, it's always the number dangling on the end, but that only works if it's in this form. So f of x equals 6. F of 0 equals 6. So the y-intercept is x-coordinate 0, y-coordinate would be 6, or we can just say y equals 6. So let's go ahead and plot these guys. I'm going to do, I'll call this -1 right here, +1. So my vertex is at -1/2, 23/4, which is, what is that, 5 3/4, so just below 6. So 1, 2, 3, 4, 5, 6. I'm just going to do this. So -1/2, 23/4. So -1/2 would be here. 23/4 would be about right here. My y-intercept is 6. So this is going to be my equation for my axis of symmetry, is going to be this imaginary line, x equals -1/2. All right, so here is my vertex. -1/2, 23/4. Here's my y-intercept, 0, 6. And I know this point right here, 1/2 of a unit. So if we go this distance from the axis of symmetry to the y-axis is 1/2. So if I go 1/2 to the left, I get this guy's buddy point. I know is -1, 23/4. Just an extra point. And now notice, we know that this guy opens up. So we don't even have to bother to find x-intercepts. So that's an awesome thing, a good feeling that we don't have to go through that work. So just make sure that you have your vertex correctly and you have your leading coefficient correct if it's positive or negative. So opens up. No x-intercepts. Only based on the position of the vertex. If the vertex fell below the x-axis and it opened up like our first problem, then we definitely would have x-intercepts. Now, we really don't have enough to plot here, so what I would do is take the time and pick a couple more points to get a feeling on exactly how this behaves. An easy input would be 1. We put 1 in, we get 8. So if I put 1 in, I'm at 8 right here. Right, now I know if I go 1, 2, 3 tick marks over, 1, 2, 3, I'm at the axis of symmetry. So I can go 1, 2, 3 tick marks over and get this point right here also. I'm going to plug in 2, and at 2 times 2 is 4. 6, I'm at 12. So at 2, oops, let's do it nice. At 2, I'm at 12. So 8, 6, 7, 8, 9, 10, 11, 12. I'm up here. And I feel as if now I have enough points to fairly graph my quadratic function. I think Alex asks you to plot 5 points. So you're going to have at least 5 points. If you have the vertex, the y-intercept, the y-intercept's partner point, there's 3 right there. All you need to do is find 2 others. If you have the x-intercepts, you can use those if they're plottable, and you'll see what I mean in a minute. All right, so now let's finish this up. The domain, all real numbers. The range, well, the range, all the y values fall above the vertex. So the range contains the vertex, 23rd, 4ths, and everything above it, or shooting off to infinity. The end behavior, we would say up to the right and up to the left. Okay. All right, one more example, kids. And then you should have plenty of examples to get working on some of this 8.3 stuff. So f of x equals 2x squared minus 8x plus 3. Oh, plus 5, I can read. All right, opens up or down? Leading coefficient is positive, so it opens up. So we know we're going to expect this, right? Let's find the vertex. The x-coordinate of the vertex is the opposite. I'll write it down. All over 2a. So it's the opposite of negative 8. All over 2 times 2. There we go. We have a nice value. So 8 over 4 is 2. To find the y-coordinate of the vertex, plug in what you got for x back into the function. So 2 times 2 squared minus 8 times 2 plus 5. So 4, 8, negative 3. So therefore, my vertex is equal to the points 2, negative 3. Right? Now we know our equation of the axis of symmetry. It's always x equals, don't forget the x and the equals, x coordinate of the vertex, x equals 2. Y-intercept always 1, set x equal to 0, and if x is 0, we get 2 times 0 squared minus 8 times 0 plus 5. So as always, the first 2 terms cancel out, we just get 5. So therefore, the y-intercept is equal to 0, 5, or just simply y equals 5. All right, let's plot these guys. So this is 2. My vertex is 2, negative 3. So here's my coordinates of my vertex, 2, negative 3. 2, negative 3. My y-intercept was 0, 5. Wow. 1, 2, 3, 4, 5. Way up here. Only one y-intercept. 0, 5. All right, my imaginary axis of symmetry helps us graph it. So this is x equals 2 is my equation of the axis of symmetry. So now this point is 0, 5. It's 2 steps to the axis of symmetry. So I'm to the left, so I'm going to go 2 steps to the right. And I already know that that point is going to be 4, 5. And I promise if you stick 4 into that equation, now we can see it is going to cross the x-axis. So we do need to find the coordinates of those points. So let's do that. So to find the coordinates of the x-intercepts, we find the zeros of the function. So we set the function equal to 0. So we're looking for the inputs that produce an output of 0. We can try factoring, but I'll tell you right now, I'll save you the headache, this does not factor. We could divide the 2 out and complete the square, but I don't want to work with 5 halves. So I'm going to use the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So for this example, it would be positive 8 plus or minus the square root of negative 8 squared is 64. Remember, the number under the radical first is always positive. Negative 4 times, minus 4 times a times c all over 2 times 2, which is equal to, notice if we eliminate this part right here, we get 8 over 4, which is 2, which is the x-coordinate of the vertex, not a coincidence. 8 plus or minus the square root of 64 minus 40 is 24, all over 4. All right, now we have to keep in mind everything we learned in chapter 7. The square root of 24 needs to be simplified. The square root of 24 is not simplified. It can be broken down into 4 times 6. So the square root of 4, square root of 6 is 2 square root of 6. So we're going to rewrite this as 8 plus or minus 2 square root of 6 over 4. I'm going to break this up into 8 over 4 plus or minus 2 square root of 6 over 4 to help me simplify. So 2 plus or minus 2 and 4 result with a 2 in the denominator. So therefore, my x-intercepts are 2 minus the square root of 6 over 2 and 2 plus the square root of 6 over 2. So now these are tough to plot. So this is when you're going to pull out your calculator. You're going to do 2 minus the square root of 6 over 2. And if you do this correctly, this is about equal to 0.8. One place after the decimal is sufficient for graphing purposes. And if you plug this into your calculator, you should get about 3.2. So my x-intercepts are 0.8, 0, and 3.2-ish, 0. So let's see if that makes sense. So if I go to 0.8, which is about right here, and 0, right before 1, and then 3.2 would be right here. That looks like it makes sense. It's 1.2 to the right of 2 and 1.2 to the left of 2. So there we go. I think we have enough points. If you want to, better gauge the steepness, you can pick a couple more points. Okay. So the domain, negative infinity to infinity. The range, well, it's all the points above the y-coordinate of the vertex. Negative 3 to 0. Has a minimum value of negative 3. It occurs at 2. Did I forget that for the last one? And behavior. Up to the right. And up to the left. It goes up and up forever. There we go. All right, I forgot to write down the 8.3 assignment. So to do, I don't know where I put it, so to save time, let me see, is it here maybe? Let's see. I don't have it. So, all right, to do, check Blackboard. I have to find those papers. Sorry. Thought I was so prepared. For 8.3 to do, under the to do section. All right, there is one more part to this. It's additional information that's not in your textbook, but it is in ALEC. So quadratic functions of the form f of x equals a, x minus h squared plus k, up next. So it's sort of supplementary to 8.3. It's only in ALEC, and we will cover that in our next lecture. Thanks, guys.